class. In this lesson, we're going to take a look at exponents in scientific notation, and that's section 6.5 out of our textbook. We've got a definition of exponents, I hope you've seen before, where you've got a base to a n, and n is the number of a's you have, the product of a's. So, for example, down here, if you've got 2, and then to the power of 5, it means that you have 5 2's. And then the number a is the 2 in this case, is called the base, and the number n is called the exponent. So 2 is the base to the 5th power, that's the exponent, and so it would actually mean multiplying 2 times 2, which is 4, times 2, which is 8, times 2, which is 16, times 2, which is 32, is the way that these work. Okay, so on these, what we are looking for is to rewrite them another way using exponents. And so here we can take this 3 and count that there's 1, 2, 3, 4, 5 of them, and we can rewrite this to be 3 to the 5th power. And if you actually multiplied it out, you get 243. Here we've got 2 to the 4th, which means 2 times 2 times 2 times 2. And if I multiply this, this would be 16. Here, if I have 0 to the 6th power, 0 to any power just means 0 times itself as many times. It's still going to be an answer of 0. Here, negative 2 to the 4th is negative 2 times negative 2 times negative 2 times negative 2. And here, what we need to look at is if I multiply these two together, negative 2 times negative 2 would be positive 4. If I multiply that by negative 2, that would give me negative 8. If I multiply negative 8 by negative 2, I would get a positive 16. 16, not 14, sorry. 16 would be my answer there. Now, what that means is that if I have a negative raised to an even power, my answer will be positive. So a negative raised to an even power, the answer will always be positive. And I'll throw that over here. If I have a negative raised to an odd power, the answer will be negative. For example, if I have negative 3 to the 3rd power, the answer would be negative 27. Okay, here is a little bit different situation because what this is saying is I've got a negative multiplied by 2 to the 4th. In other words, I've got negative times 2 times 2 times 2 times 2. So here the negative doesn't come into play until the very end. I do 2 to the 4th first, figure out that it's 16, and then multiply it by negative. So it's negative 16. Now here finally 5 to the 1 is the same thing as saying I just have one copy of 5. One copy of 5 is just 5. So sometimes we'll have it to the 1st power, and that just means that you have whatever number you're looking at. All right, so here we've got same base exponent multiplication. Whenever you have the same base, what you're supposed to do is just count how many copies of that you have. So if I have x to the 3rd, that's just saying that I have 3 x's. And then x to the 4th is saying that I have 4 x's. So in all, if I add them together, that's saying I have all the x's in one line, which would be x to the 7th power. The rule is, if you have the same base to, it doesn't matter if they're the same exponents or different exponents, you add the exponents if you're multiplying the bases. Okay, so let's use the product rule here to expand these. And what we're going to be looking at is 2 to the 5th times 2 to the 9th. If I actually expanded them, I would write out 5 2's right here, and then 9 2's right here, and then I would add them all in the end. But in the end, I really just have 2 to the 5 plus 9 power, which means I have 2 to the 14th power. I would have had 14 2's if I expanded and wrote all those out. And a similar situation would have been here if these had the same bases. This is 3 to the 2nd. This is 5 to the 4th, so I don't make this 15 to the 6th power. That is not what this is. This is not correct. You don't multiply the numbers and then add the exponents, because here we didn't do that. We didn't make this 4 to the 14th, if you think about it. We don't multiply the bases. We're counting how many there are. So here in this situation, I can't actually simplify it using the exponents. What I'd have to do is actually figure out that this would be 9 times 625, and then actually multiply that out to get a final answer. Okay. And so really, we would have just said that this one was not possible if you had it on the lab. So, raising a power to a power. What this is showing is that I've got y to the 3rd 4 times. In other words, I have 4 copies of y to the 3rd. So I can write y to the 3rd, y to the 3rd, y to the 3rd, y to the 3rd. And if I'm using my property from the last slide, we would really have 3 copies of y, another 3 copies of y, another 3, and then finally in last number 3, which means in all I have, if I counted these all up, I'd have 12 copies of y. So there's a quicker rule to play with that, and that's just saying that if I have a base raised to a power raised to another power, I multiply the powers. 3 times 4 is 12, and so that would have quickly got me there in this particular problem. So let's try a couple. Here this is saying I've got 2 copies of 2 to the 3rd. The quick solution is just to multiply these 2 together and get 2 to the 6th power. Over here I've got negative 2 to the 3rd power. Here I'm going to multiply that to the 4th power, and so it's going to be negative 2 to the 12th power. And then you can also reduce that because I said earlier that if I have a negative raised to an even power, the answer is going to be positive. So this is actually equal to 2 to the 12th. If I had left it as negative 2 to the 3rd, that part's odd, and I would have to leave the negative there. That's equal to negative 2 to the, I'm sorry, I didn't need the parentheses there, I'm sorry. Negative 2 to the 3rd like that. If you raise that part, it's still the whole thing to the 4th power. That's why the negative goes away, is because we're raising it to an even power at the end. Okay, so now we're going to divide same bases with exponents. Here we've got x to the 7th and x to the 3rd. And so what that looks like is I've got 7 different x's up top, and then I've got 3 different x's on the bottom. And we learned in a previous lesson that if we have a variable or anything divided by itself, it turns into a 1. And so if I write it this way and cancel those out, then that's just crossing out a 1. So if I take x divided by x, it's just a 1. X divided by x here is just a 1. And so what you look at is what's left over is x to the 4th. And here you can see my x's would have just turned into a 1 on the bottom. And here I've got x to the 4th power. Now what that leads us to is that down here we are just saying that we have a base on the bottom and top. What I'm supposed to do is just subtract the top one by the bottom one. So here I really just took 7, subtracted 3, and got the 4. Okay, so let's take a look at an example. Here I've got 3 to the 7th over 3 to the 5th. Now please don't reduce the 3's and make that a 1. It doesn't quite work out that way. We're trying to say that, and the reason it doesn't work out that way is I could actually type up that I have 7 3's up top, but I don't really think I need to, but I can't cancel the 3. It's the bottom line, is what I'm saying. So I've got, well, let's go ahead and write it out. 1, 2, 3, 4, 5, 6, 7 of them, and then 5 on the bottom. And then I would cancel them out this way. Cancel 1, 2, 3, 4, 5 of them, and so I'd be left with 3 to the 2nd because there's 2 3's up top. But the faster way is just to see that this is 3 to the 7th minus 5, and that gives you 3 to the 2nd, which is what we just had. Okay, now here we're going to take a look at a couple examples where there are special cases where I might have the m and n be the same. In this situation, we're saying, well, what if they are the same? They're both 3. So this is x to the 3rd over x, or yeah, x to the 3rd, because m and n are both the same. And so what this turns into is x to the 3rd over itself, and anything divided by itself is going to cancel like this, and the answer would be 1. So if the numbers are the same, you still get 1. Okay, just like we've had before. But here in this next situation, they're going to be a little bit different because the top number is going to be smaller than the bottom number. And so it's going to look like this. So when we go to do our subtraction, it's going to be a little different. If I actually expand it, it's a little bit easier than if we just use the rule. See how there's 3 up top? And if I cancel them out like this, then I can see easily that there's 2 on the bottom. And so that's going to leave me with 1 over 2x on the bottom. And that gives me 1 over x squared. Now, another way of looking at that would be that if I had done x to the 3rd minus 5, notice I'm taking the 3 and subtracting 5 from it. What that turns into is x to the negative 2. And if I have a negative exponent, what we're going to learn is that they need to go to the bottom. Basically, this is over a 1, and I would bring it down to the bottom and make it a 1 over x to the positive 2 power, which is what I have there. So here's the visual way of seeing how it cancels, and then here's kind of how the rule plays itself out. And so this is, again, the next rule that I wanted to talk about, is that when I have a negative exponent, you move it to the bottom. So here's what that looks like. If I have 7 to the 5th power, 7 to the 8th power, I can subtract and actually make this 7 to the 5 minus 8. And that would give me 7 to the negative 3rd power. but you don't leave it as a negative third on the top. What it turns into is 1 over 7 to the third. And another way of looking at that would have been the way I don't actually use, when I mentally go through it, I don't usually do it this way. I usually think through these 5 will cancel out with 5 of these to leave 3 on the bottom. That's more how I do the math mentally, so that way I get the 1 on top over 7 to the third. But again, the reason why is what I just explained, if you want to rewind and look at it, about how I just canceled those out. Now here again, these are the same base, same exponent. When you cross them out, the only usual mistake that I'll find people say is they'll say that's 0, but the answer is actually 1, because anything divided by itself is 1. Okay, and then let's deal with some more negative exponents here. We've got 5 to the negative 4 and 5 to the 7. There's a couple ways you can do this problem. As I said earlier, you can have negative exponents probably flip. So I could go ahead and rewrite this problem to be 5 to the 7 and then over 5 to the 4th, because whenever it's a negative exponent, you want to move it to the bottom of the fraction, and right now it's underneath. 1 is underneath there, so I'd move it down to be where the 1 is, and then I would cancel from there. But I can also, the way that it's written, just add, because I've got the rule that says if I have bases at the same level, I can add the exponents. So I can just go ahead and say it's just 7 minus 4, which is 5 to the third. And the same situation would have been here. I have 4 on the bottom, take away from 4 up on the top, and I'm left with 3. So 5 to the third, either way that you look at it, either using the division rule or the multiplication rule. Here I've got a power, negative power raised to a power. I can multiply them first and get 2 to the negative 6th. And then what you want to remember is that you can't leave the negative exponent on top. It's really over a 1 right now. So I need to take this 2 and bring it down to the bottom and make it a 2 to the positive 6th power. When I move it to the bottom, it gets rid of anything that was on top. So my final answer is 1 over 2 to the positive 6th power. And then here, I've got lots of negatives happening. These negatives in front don't cause the flipping. It's these negatives here that cause me to flip the fraction. So I actually want to start off by making it negative 3 to the positive 7 up top, negative 3 to the positive 2 on bottom. Now the way I wrote it just now is incorrect, because I need to have parentheses still grouping the negative sign with the actual base. And then from there, what I want to do is go ahead and subtract my exponents, or reduce my exponents. I've got 2 here, 7 here. So these 2 are going to cancel out with 2 of these. So this whole base is canceling out with 2 of the top base, and that's going to leave me with a 5. So this is negative 3 to the 5th power. And here I don't actually need the parentheses, because the negative raised to an odd power is still going to be negative. So I can leave it like that, or I can say it's negative 3 to the 5th. Either answer is sufficient. Over here I've got negative 3, negative 3. I can flip them, but it doesn't matter. So technically the correct algebraic way of doing it is rewrite it to have positive exponents and raise it to the 3rd power and then cancel it. But anything divided by itself, even a negative exponent divided by itself, is going to be 1. So the bottom line, the whole answer turns to be 1. Okay, scientific notation is the next thing we're going to talk about, and I'm going to break to make a separate PowerPoint, or a separate link. So just go ahead and click on the next link to watch scientific notation.